So students, while drawing this, I had talked about focal length. Okay, what focal length is? Focal length. I had asked everyone to give the definition of this focal length, for principal focus, everything. I don't know how much. I think some few students have sent, but after watching this video completely, I need everyone to send me, because I'm not going to give any notes without your answers back. Please keep in mind. Now, here, what focal length is? It is the distance between pole and the principal focus of a spherical mirror. So this distance is known as focal length. So for spherical mirror, the radius of curvature, this is the radius of curvature, is found to be twice the focal length. You can see here, from here this distance is twice, right? This distance is known as focal length. Okay, for a spherical mirror, radius of curvature is found to be twice the focal length. That is, r is the radius of curvature, it is twice the focal length. Focal length is represented by small f. Focus of spherical mirrors lies midway the pole and center. Already I have talked about this, right? So once again I'll repeat. The distance between the pole and the principal focus of a spherical mirror is known as focal length. And for a spherical mirror, radius of curvature, that is this radius. So this is a sphere, right? So this becomes the radius. So radius of curvature is twice the focal length. So r is the radius of curvature. Radius of curvature, it's a small mathematics which you have already learned about sphere. Okay, so radius of curvature is twice the focal length. F is the focal length. Focal length is represented by small f. Okay, keep in mind. So students, after this video, I need everyone's answer. Whatever I have asked in the first class, every definitions, I need it back from you students. If you are not going to send, then I'm not going to give any notes for any of the students of 10th standard, because you can't attend the class. So I have sent the videos. After sending the video, I'm sure you can understand each and every concepts. After knowing the concepts, I need your answers. So by tomorrow, I need everyone's answer. You have full 24 hours. Utilize it and send me the answers. Okay, now let's move on. Now let us see with the image formation by spherical mirrors. So image formation of spherical mirrors. Spherical mirrors includes both concave and convex mirrors. Now let us see the image formation by concave mirrors. So you have a concave mirror here. This is the principal axis. So this is the pole. This is the center of curvature. This is the focus, right? Now there are many instances, that is position of the object. Please do read your textbooks. You have these things in your textbooks. You have to watch it clearly. After watching my video, please go through the textbook so that you can understand each and every concept thoroughly. Now, when object is placed behind center of curvature, behind center of curvature means here, right? When object is placed here, what happens? So this is the object. Name it as A and B. Okay, this is the object. It is kept behind the center of curvature, that is beyond C, right? Beyond C, what happens when object is placed beyond C? Now the ray passes through the principal focus and becomes parallel right? Another ray incident on the mirror passes to the focus, right? So we'll get the image here. Let us name it as A dash B dash. Can you see it clearly? Students, I think you can see clearly. So now what's the result we get? So now the result of this, when the object placed behind C, what happens? Image is formed between principal focus and center of curvature. You can see here, image is formed between center of curvature and principal focus, right? Here you have formed the image is formed, and image is formed is real. Image formed is real. It is inverted. So here the image formed is inverted like this, upside down, okay? And image will be smaller than the size. The object size is this. When after reflection, the object size is this. That is, you will get smaller image than the actual size, okay? Now the next position is when the object is placed at the center of curvature at C. So this is your concave mirror. This is your principal axis. So here you have center of curvature C, principal focus F. It is a pole, right? Now when the position of object is placed at the center of curvature, so now object is placed in center of curvature, right? What happens now? One ray incidence to the mirror. After reflection, it passes to the focus, right? Another ray passes to the focus, and we get where we get image. So image we get here, right? A dash B dash. So we have image over here. Now in this case, when the object is placed at center of curvature, what happens? Image is formed at center of curvature at C itself, and the image formed is real inverted. Once again, you will get inverted image. So this is the image. It is inverted. Now what about the size? You can measure here the object size, and after reflection it is same. Size is same size as the object. So this is the case when object is placed at center of curvature. Students, I think you understood both the cases. Beyond C, what happens? Image is formed between principal focus and center of curvature, and the image formed is real but inverted, and the size of the object will be smaller. When object is placed at C, what happens? After reflection, image is formed at center of curvature, and the image is real inverted, and the size of the object is same as the object size. Image is same as the object size. Size of image is same as that of the object. Now let us go with other position, that is when object is placed between principal focus and center of curvature. Now what happens if object is placed between principal focus and center of curvature? So this is your principal axis, this is your pole, this is the center of curvature, this is the principal focus. So object is placed between center of curvature and principal focus. So where should be the object? Should be here, right? So what happens when we keep object here? So light incident on the mirror passes through focus. Another ray is incident through focus and passes over here. One minute. So this is the center of curvature, right? While drawing, you have to draw very clearly. This is my rough sketch because in order to understand for you people, I have drawn. This is a rough sketch. Please note it. You have clear image in your textbook and page number 166. Go through it. So in this case, what happens? When the object is placed between center of curvature and focus, what happens? The image form is beyond center of curvature, beyond C, and the image is real, inverted. Now, what is the size of the object? As you can see, the size of the object and size of the image. So you will get the magnified. Magnified means the size of the object is large. Size of the image is larger than the object. Now, next case, when the object is placed at principal focus at F, what happens? So now what happens when object is placed at principal focus? You have center of curvature here, principal focus here, and pole over here. Now it is asked there to keep the object at F, right? That is principal focus. So what happens now? When incident ray passes through the mirror, it is reflected back in this way. Another ray incident on pole and gets after reflection passes in this way. So this continues. So the conclusion, what the conclusion is now, the image formed, where image has formed, can you see anywhere the image has formed? No, right? So object is at infinity. You can't get the image of the object. Then the image formed is real, it is inverted, but it is at infinity. Can you observe it? Look through it. The image formed is highly enlarged. Highly enlarged image you will get. Okay, highly enlarged means it is at infinity. Can you go through the image? You have to think about this. Okay, and now let us see when object is placed between pole and principal focus. Between pole and principal focus, what happens? So this is your center of curvature, this is the focus, this is the pole. Now object is placed between principal focus and the pole, right here. Now what happens when this goes? Now the ray gets incident to the mirror and it gets reflected back along the center of curvature. and the ray passes in this way. Another ray reaches the pole, and after reflection, so here our image is formed. This is the image formed. So here we will find the image, that is, in this case image is formed behind the mirror. So we are not able to see this because image is formed behind the mirror. So when object is placed between principal focus and pole, what happens? We get the image behind the mirror. Image is virtual or erect. We had discussed this, right? Virtual or erect. Like it appears to converge. Appear to converge. Actually it is not converging. It appears to converge, and the image formed is behind the mirror, right? And the size, you can see object size is this and the image formation is this. So size is larger. The size of image is larger than the size of object. Now lastly, when the object is placed at infinity, somewhere in infinity, if the object is placed, what happens? So you have concave mirror over here, right? So this is your center of curvature, this is your focus, and here is the pole. Okay, now from at infinity they have asked, so from somewhere in the infinity the ray falls, is directed towards the mirror. What happens now? It passes to the focus, right? And somewhere here it gets reflected. After reflection, ray comes back and goes on. So image is formed at focus, right? See, when sun rays falls on our eye, what happens? There takes place the reflection and we are able to see the objects. The same thing goes here. Okay, you can see distant objects. Okay, from there the object sunlight falls on that object, reflection takes place, and reflection takes place to towards our eyes, and we are able to see the things. The same things goes here. So in this case, image is formed at focus. Image formed is real, but image is inverted. And you can see the size of the image. It is a point size because it is in infinity. So you can see it is really a very tiny size. The image formed is of very tiny size. For example, you can see the twinkling stars. You can see a big star which is larger than the sun, right? So you can see it has a tiny particle itself, right? You can take it as an example. Okay, for infinite distance, at infinite distance you can see the star as a point size image, right? So these are the image formation of concave mirrors. Now let us see the image formation by a convex mirror. So now this is your convex mirror, right? Now here the pole is here, focus is here, and center of curvature over here. So what now? We will be seeing two instances when the object is placed at infinity. So what happens when the object is at infinity? Now let us see. Okay, so the object is somewhere here in the infinity. It incident on the mirror. After reflection, after reflection what happens? You have to see that, right? It passes to the focus. One more ray in the infinity incident on this. And what happens? It gets, after reflection, it meets over focus. So what is the conclusion now? Image is formed. Where the image is formed, as you can see, image is formed over here, right? So the image formed, what happens to the image? So image formed is at focus, right? Image formed at focus. How about the images? It will be virtual or erect. Now what about the size of the object? Here it is, then you have to think from infinity. So size of the object will be highly diminished. Highly diminished means, I need answer from your side itself. Highly diminished point size. Tiny size, right? Now this is about when the object is placed at infinity. Now let us see when object is placed between infinity and the pole. Okay, now what happens? An object is placed at infinity and the pole. So this is your convex mirror. Here is the principal axis. So pole is over here, focus is over here, and center of curvature is over here, right? Now what happens? This is actually object is placed in the finite distance between this object is placed. So as the rays fall through the mirrors, after reflection what happens? After reflection it passes over focus. One more ray passes over here directly to the center of curvature and passes along the same path. So this is the case where here we will get the object A dash B dash. Now when the object is placed between infinity and the pole of the mirror, what happens? Incidence on the mirror, after reflection it passes to the focus. Another ray passes through. So the incident ray incident on the mirror, after reflection it passes to the focus behind the mirror. Another ray passes incident on the mirror and it passes to the center of curvature, passes back along the same path. So now what about the conclusion, where the image is formed? You can see, as you can see, image is formed between pole and principal focus. Between pole and the principal focus. So image is formed between pole and the principal focus. And the mirror, where it is formed? It is behind the mirror. So mirror, the reflecting surface is this. So image formed is behind the mirror. Okay. Image is virtual and erect. And what about the size of the object? It is diminished. Diminished means very small. So this is about image formation of the spherical mirrors. You have seen both image formation in concave mirrors as well as image formation in convex mirrors.